Welcome back to the third episode of Hacking 1Password. If you feel lost somewhere in the middle, you can always go back to the previous episodes to catch up. For this episode, I will try my best to show how I approached decrypting 1Password earlier. I want to show that with a logical mind and good enough internet knowledge, we don't need to have a PhD to start hacking something that looks difficult. Before we get started, let me quickly give a shout out to our sponsor, Integrity. Integrity is an ethical hacking platform. Sign up using the link below to become an ethical hacker today. Last time we stopped at decrypting 1Password on paper, and this time we will decrypt 1Password together. Let's get started. This time we start with a wonderful proxy tool, Burp. Here we have 1Password login form and Burp suite side by side. We enter my email address, master key, and my password and click Login. We can see in Burp, the first call is something we have already covered in the last video. Email, secret key, and the next one looks a bit strange. It has session ID and user A, and the response has user B. And after that, we have the final verification requests, which is something we have covered in the last video, the KID, encryption, IV, and data. Also, if you pay close attention, there is also a header added here, the MAC. A short summary here. Step 1 and Step 3 looks familiar to us with the use of master key as shown as the last video. We should be able to decrypt the response of Step 3, but we need to figure out the value of the master key and what is the MAC value in the header. This time, darthnode.org can't seem to help, because we need something that is focused on the authentication flow of 1Password. Since we don't want to reinvent the wheel, let's have a quick GitHub dive to see what we can get. The help that we are looking for is 1Password unofficial desktop or command line client. Because in order to build a client, you need to have the authentication with 1Password server. And if we can read the interaction between the client and 1Password, then we can figure out what's going on behind the scene. And this is what we need, Dmitry Yakimenko's 1Password unofficial client. In the README, we can see this line. It looks about right. It even has an overview of the steps involved in the source code. Step 1. Request to initiate a new session. Step 2. Perform an SRP exchange. Step 3. Verify the key with the server. And from Step 4 onwards, it is about getting account info, and it looks like this is just plain decryption. Let's do a quick analysis on this code. Step 1 should be the first API call we've seen earlier in Burp. Step 2 is the user A, user B thing we saw earlier, and the SRP stands for Secure Remote Password. And it also gives us a hint on the MAC signing process. Step 3 is the final verification. From Step 4 onwards, we can see session key is used in every step. And this session's key is probably the master key that we talked about in the last video. So it is clear to us that we need to figure out how to get the session key in order for us to perform the decryption. In other words, if we can figure out the value of session key, then we should be able to use the method I mentioned in my last video to perform all the decryption and encryption here. The session key was computed from srp.perform and then passed to the MAC request signer. I don't understand the code in the srp.perform. I suppose you don't understand as well. But for the MAC request signer, there is an interesting crypto method, crypto.calculate session HMAC sort. By tracing the source code, we can see it is calculating the HMAC of the session ID, and the sort is a fixed secret value. The secret is he never wears a Mac in the pouring rain. Very strange. And next to the secret, it is the session key. And before you know it, we actually have collected enough information to decrypt 1Password now. Remember back in my old video, I said we don't actually need to know any cryptography knowledge, and this is true because if the 1Password web version's JavaScript is doing all the work for us, so why would we bother to understand everything? We can just modify the script and get the values we want and move on. In this case, we want the session key, which is the master key of the whole 1Password authentication series. And we happen to know that it will certainly be passed to a function along with the fixed secret HMAC value. So we can just search in 1Password's JavaScript and look for the same function. There we go, it looks exactly like the function we saw earlier from GitHub. Here we can just use an old but effective alert function to get the value in the runtime and use it to decrypt 1Password. And we pass it to the script written by .null and pass the relevant information to the script respectively. Ta-da! A decrypted 1Password is right in front of you. Here we are going to use the script provided by the .null.org, and we copy the plaintext session key value to the script, and we will enter as the AES256 key, and then we get the IV value from the response, and also we provide the encrypted data in the response. And here we go, we can see the plaintext decrypted data. To wrap up, in this video we talked about how to decrypt 1Password alongside with Burp. And by leveraging the existing resources on the internet, we can understand the process just enough for us to begin hacking 1Password. Because after the decryption, 1Password would just look like any other web applications to us. And this is what we will cover in the next video. Putting everything together and start hacking 1Password together.